going to exhibit different characteristics, like the resonance that we have talked about. So for now, we're going to look at just an example or illustration of one of the resonance structures of a substituted benzene that we call aniline. Aniline is a substituted benzene that has got an amine group at one of the points in the molecule. So I'm going to just have a small illustration, and then we just have a summary of what we have discussed and then finish that case. So as I've mentioned about the concept of resonance structures, this is going to assist us in trying to interpret and figure out how electrophilic substitution processes take place, or nucleophilic substitution in these benzene molecules and other organic reactions. So in this case, as I've said, that the resonance structure gives a possible configuration for either the double bond or the lone pair of electrons on atoms, especially for the substitutes which have been included or added to the benzene molecule. So I've talked about an example of aniline. What I've said is that aniline is a benzene which has been substituted using that amine group. So in this case, we shall have this molecule for benzene, and then we are going to have different resonance structures which are dictated by the lone pair of electrons, which we have said, which are at this particular point. So we have a lone pair of electron at this point in nitrogen. So in this case, we are going to see how that one behaves. Of course, when this lone pair of electrons move at that point, is that will be the subsequent step that is going to occur, and then we are going to have a resonance structure for that second molecule that is going to have those double bonds at those points, and then we have an excess charge there, that is a negative charge for electrons. And this now, there's a deficit of the number of electrons that were present there at this point, and we shall have a positive charge at that particular point. So it forms a polarized molecule of that nature. So from this second molecule that we have seen, there's a formation of a double bond at this point, and then there's a net negative charge at that point and a positive one there that is forming a polarized molecule. So we have this charge moving to this point. Of course, because of stability, this bond for the arene molecule will move to that point, and then we shall have a negative charge, net negative charge at that point, and that will form a resonance structure with the second molecule, of course, which is going to also have these double bonds here, and then there's a positive charge there from the initial electrons that were moved. So if this charge moves to this point, and then this one is going to move to that's a double bond. So we're going to have a net negative charge there, and then a double bond at this point and this, and then we shall have this positive charge for that amine, and then of course we are going to have a next step. So those double arrows means that the molecule can resonate between those points, and those are the different representations of possible configurations for the double bond and the lone pair of electrons that were moved from the amine group. So in that case, for the last one, it's going to form a bond at that point. So this one is going to move here, and then this one is going to move at that point. So that pair of electrons has moved through the cycle, and then we shall have that molecule forming now a stable one. That was the initial molecule that is amine, and then we have So in this case, there are various steps that we're going to look at and see in some of the reactions, like electrophilic substitution aromatic reactions, whereby you find that the restoration of aromaticity in a compound after a reaction or an interaction with a nucleophile or an electrophile. So in this case, we have these kind of resonance structures that occur when, of course, a molecule like an alene is interacting, And this is going to dictate the subsequent reactions of this kind of a molecule. So in this case, this is very basic for the structure of benzene, because next we're going